it's really a question of how to locate these 4 corners of this H domain. To answer this question, we need to find out the 4 indices of these 4 points on the J and K edges, as shown in index 1, index 2, 3, and 4. So the first 2 elements of the scalar, the S1 and S2, they will be applied respectively to, in this case, J and K directions to calculate the scaled length. And based on the scaled length, we will calculate where the index, the 4 points will be located. And I will cover that in the next slide. So once you find out the where the 4 corners are, you can call the 4 corners by using the index system we just mentioned before, and then assemble them into connectors, like the little segment shown to the right. Once you have the connectors, you assemble into the domains. And the other important issue I need to mention here is to handle the butterfly faces with high curvature or slope discontinuity, we need to make sure the shape information will be maintained once the topology change is conducted. The way we do that is to project the resultant domain, the new domains, back into the original database faces to make sure they are constrained to each other. So this slide answers the question I just mentioned in the last slide, and how to snap the points on a connector. Say you have a connector here, those 2 points with a color in red are our targets. So we need to find those 2 points, and only 2 points, not 3, not 1, or not 4. And then once you calculate the scaled length, you will find out 2 other target lengths that will determine where the ideal location would be for the 2 points. But most of the cases, you don't have 2 points that are sitting right on the ideal locations. What you have is you have them very close to the locations, but you have to snap the points and figure out which one is the closest, kind of move around a little bit like that. So 4 conditions are used in this little procedure. The first two conditions are more like a physical conditions. So they are aimed at snapping the points when they are very close to the ideal locations. The last 2 conditions, they are more like artificial conditions. The goal is to improve the numerical stability in this case. So the 4 conditions, they work together. A point will be snapped whenever one of any following the 4 conditions is met. And also, once you snap the point, then you have to figure out how to deal with all kinds of scenarios. Say, no point is snapped, or only 1, or 3, or something like that. And also, once, say, if you would like to propagate the topology into certain condition, you have to make a check at each butterfly interface. You have to make sure all the snapped points are exactly the same over there. You don't have conflicts at the interfaces. The script is designed for tackling the complicated scenarios. For instance, a multiple domain butterfly face. In this little example here, you can see 2 faces. The first one, face A, is a butterfly face. Face B is a non-butterfly face. In other words, you want to create new domains in the butterfly face A, but you want to keep the structure of the butterfly face B. So it actually involves several tasks in here. The first one is you have to detect the shared edge between the face A and B. Then you have to sort the connectors on the multiple connector edge. This is a requirement of the glyph command we're going to use in the code, because if you're going to use the several things, in this case, you have one edge that consists of 3 connectors. So if you're going to assemble these 3 connectors into one edge, they have to be connected one to another in certain order. And the third task is to remove the original connectors that are inside of the butterfly faces. And the little procedure to the right shows you how to actually find the shared edge between the face A and face 1. And for this feature, actually, I have evaluated about 2 methods. The first one sounds really good at the first place. It's like, how about I just join all the domains in the face A, and make it just one single edge domain, this saves me a lot of effort. In other words, I don't have to deal with step 1, step 2. I just completely deal with the step 3. It sounds really good, but if you look at a little second to right at the bottom, in the Glyph, I figured this one could be really time-consuming in some cases because if you use the command gg : domain join, so if you're going to join the domain together, you have to first make sure all the domains are connected one to another. And that could be very time-consuming in the complicated cases. So eventually, I quit using this one. Instead, I use the second method, which is kind of similar, but the second method, I will keep all the domains in the butterfly phases. I will not join them, but I will locate the new connectors or domains using a global index system, which is independent to the domain index system. So I kind of dodge that bullet, and also I can do my things efficiently. And this one answers the question of how to really sort an edge with multiple connector edge. In this little picture here, to assemble a new domain like this, you need to assemble actually 4 edges into this domain. The O-rib connector 1, then edge connector, and O-rib connector 2, and then a multiple connector edge. So here we are really dealing with 2 edge structures. The first one is colored in blue, which is single connector edge, which is very easy to deal with. Then it's multiple connector edge. We need to sort the connectors to make sure they are called or they're placed, arranged in a Tico list in certain order. For instance, in this case, I want it to be arranged like 5, 4, 3, 2, 1. The multiple connector edge manager is implemented in this case to handle the scenario like this. So the initial, for instance, the initial order is 4, 1, 5, 3, 2. It's all messed up. And to put them, all the connector in place, I need to run this little procedure to switch the locations when, probably I need to show a little bit. So in here, say we start with the O-rib connector number 2 in that little box over there. So apparently the connector 2 is not really adjacent to this connector. Connector 1 is. So what we do next is to switch the 2 and 1 in the list, and likewise I would switch like 4 more times, and that's how this is done. For the future work, GridGen is the first generation of our meshing product. And we already released the second generation Pointwise, which looks much better in the GUI, and everything is faster, the performance is good. So I need to rewrite the script using the Glyph 2. Glyph 2 is more like OO looking structure. So I need to completely rewrite the whole thing. And also I need to use the Tico TK 8.5. And in the future, the script should be able to handle more group typologies like a CH and LH, because for now it only handles OH. But that's not going to be a huge challenge because OH is the most tricky part of this application. And also, I already wrote some other Tico TK scripts for Glyph scripts for specific distributions of connectors to be applied. So I'm thinking of either sourcing them or making them a package so I can use them as a custom libraries in the future. And also, the current script only handles the H domain at the center, and that's what we prefer. But the thing is, for some users, as far as I know, they really like the H domain could be everywhere. So in the future, we need to work on that one to allow the arbitrary H domain to be specified by the users. And there are a few I have learned. I already have some ideas about how to improve them by sitting in the tutorials in the last 2 days, and I think it's extremely helpful for me. For instance, I'm thinking of optimizing the frequently used components to boost the script performance, and I think Cliff has some really good ideas, and I learned that it's going to be very helpful. And also, I'm thinking of using the advanced ticket widgets like TTK, that's really new to me, for improving the user interface. So probably could fool people a little, because right now the user interface looks very not professional. So I'm thinking about that. And also, I will be exploring the possibility of parallelizing the script for large applications. That's why I was very interested in yesterday's talk about that parallelization application. So, thank you.